Assalamualaikum and good day. This is a video presentation of experiment 4 series of parallel pump. My name is Safi Adham bin Ahmad Razani and our group consists of 5 members including Muhammad Rafli Salim bin Hassan, Kavin Kumar anak lelaki Nahindran Kumar, Muhammad Adi Shazwi bin Ismail, and finally Muhammad Eri Iskandar bin Muhammad Saidi. In this video, I will talk about the introductions. Pumps come in a variety shapes and size. The pumps are responsible for providing precise pressure to overcome the system operating pressure to move fluid at the required flow rate. A pump moves or flows liquid, but it does not generate the pressure. The pump generates the flow required for pressure development, which is a function of fluid flow resistance in the system. The goal of this experiment is to distinguish and identify how the pump works when it is in a series pump, a single pump, or a parallel pump. In this experiment, we will investigate the data graph of the pump curve obtained during the experiment. This is a pump curve series. The type of single pumps in series are shown in the figure. If the pump operates at the same capacity, different levels of head can be delivered, indicating the volume of fluids a pump can be transferred under different pressure conditions. This is a pump curve parallel. The performance of the pump is depicted in the parallel graph. The addition of a pump in parallel results in the flow rates of the pump being the same at the same head. The use of parallel pumps to overcome larger volume flows than a single pump can handle. As for our problem statement, pumps are in charge of moving liquid at the required or sufficient pressure. The issue arises when the liquid cannot transfer efficiently. When it comes to different conditions, the appropriate and types of pumps are required. To investigate pump performance, tests of single pump configurations, series pumps, and parallel pumps must be conducted. From the problem arise, our objective is to evaluate pump performance in single, series, and parallel pump configurations by measuring and analyzing fluid flow pressure. To investigate the efficiency of various pump configurations by calculating the pressure head, flow rate, power consumption, and efficiency of the pump. And last one, to compare and derive a plausible outcome from the performance curve of various pumps. Our scope in this experiment, we investigated the performance curve of single pump configurations, series pump, and parallel within the results of the experiment. During the lab experiment, there could be a few flaws and errors. The comparison of pump curve occurs within the pump involved in the experiment. That is all from me. Thank you.
Assalamualaikum and hi. My name is Muhammad Arif Shazwi bin Ismail and my number metric is MA19015. So for our experiment today is experiment series and parallel pump. So I would like to brief you about a literature review about pump. So classification of a pump. Pump can be categorized into two sections, which is the first one is positive displacement pump and the second one is dynamic pump. So into a part of dynamic pump, which is a centrifugal pump, is widely used in nowadays industry. So as you can see here is an centrifugal pump where the fluid in join to inlet 1 and then it goes rotate the impeller and to volute casing is go up to outlet discharge where it convert kinetic energy into a pressure energy. So as you can see over here in this picture, we have two ways to connect our pump, which is first one is the series system pump and the second one is the parallel system pump. So as you can see over here, we have a pros and cons where the series pump have a less expensive to upgrade. The current pump use a less horsepower and low speed operation, which is low of energy consumption and increase in reliability, while the pros in parallel pump system, which is have a smaller pump lower operating cost, and have a standby option. Where accounts for a series pump which is have a more flow space, more moving part, which means more things can go wrong and more equipment is required. So for cons for parallel pump, which is pump is must big enough for the combined flow, the pipe is must big enough, and it cannot use for high head and use more horsepower while using a multiply series. So that's all from me. Thank you.
Assalamualaikum and a very good day, Dr. Annie and fellow audience. I am Muhammad Hafiz bin Hassan Azhar, MAY at 178. Today I'm going to present our group finding on Chapter 3 Methodology of this Fluid Mechanics Lab Experiment Series / Parallel Pump Experiment. To get started with apparatus 3.1, for the first equipment we have identical centrifugal pump, which is a mechanical device designed to move a fluid means of the transfer of rotational energy from one or more driver rotor called impeller. And there are two valves used in this experiment, which is stainless steel gate valve and PVC ball valve. For the stainless steel gate valve that either allow media to flow through unobstructed or stop the fluid flow with minimal pressure loss over the valve. For the PVC ball valve is a polyvinyl chloride ball valve, which is a plastic that allow on and off valve. When turning the valve a quarter turn can stop the flow of the fluid. For the third apparatus, which is pressure gauge, Borden pressure gauge can be used to measure relative pressure from 0.6 bar to 7,000 bar, which classified as mechanical pressure measuring instrument. For the last one is pipe. PVC pipe are commonly used in water transportation due to technical properties such as high durability, high chemical resistance, and affordable. As for the experiment setup, this figure shows experiment setup provided by University Malaysia Pahang UMP for undergoing the experiment on single, series, and parallel pump operation, which currently the apparatus located at University Malaysia Pahang Pekan campus. For the valve numbering, based on the video provided in column, every location of valve used in this experiment is numbered out for our better understanding and more clear report procedure. So this is the location of valve number 1. This is the location for valve number 2. This is the location for valve number 3. This is the location for valve number 4. And this is the location for valve number 5. Moving on to experiment 1, which is single pump experimental procedure. Turn right on every valve to close the flow and turn left to open the valve flow. First step in this experiment 1 single pump procedure is to turn right on the valve number 2 to close the flow, then turn right on the valve number 3 to close the flow, and turn left on the pump switch to turn it on. Then volumetric flow can be adjusted by adjusting output valve opening. And lastly, measured value then can be recorded. Number 2, series pump procedure. Turn right on valve number 2 to close the flow, then turn right on the valve number 4 to close the flow. Turn right on the pump switch to turn on pump 1 and pump 2. And step number 4 is the volumetric flow then can be adjusted by adjusting the output valve opening. And lastly, the measured value then can be recorded. So lastly, for the experimental parallel pump experimental procedure, first turn right on the valve 3 to close the flow, then turn right on the pump switch to turn on pump 1 and pump 2. Step 3 is the volumetric flow then can be adjusted by adjusting the output valve opening. Then lastly, the measured value then can be recorded. That's all from me. Thank you.
Good day everyone, my name is Kavin Kumar and my ID number is MA19020. So today I'll be explaining the discussion part of the lab, which is entitled Lab 4 Series and Parallel Pump. As for the discussion part, we have managed to take the three different values of the experiment, which is for the single pump configuration, series pump configuration and parallel pump configuration. As for the single pump configuration, we have managed to take the three suction, pump delivery and pump single, and the net head was calculated by P single divided by rho G, and the rho is remain constant for the three experiment, which is 1000, and the gravitational force was taken as the constant value, which is 9.81 meter cube per second. So for the series pump configuration, we have done the experimental by involving the two pump in the series order arrangement, and we have managed to take the experimental data of P delivery 1 and P delivery 2 as well. So the parallel pump configuration for the third experimental was done by taking the experimental value of P delivery 1 and P delivery 2, and the arrangement of the pump was in the parallel way, which is by side in the same location. As we can see from the graph, we have after managing to take the experimental value and calculation of the net head and the volume flow rate, we have managed to take the volume flow rate for the three different experiments. As for the volume flow rate versus head for the single pump configuration, from the graph itself, we can clearly note that the head is reducing and the volume flow rate is increasing. Next, for the volume flow rate and for series pump configuration and for the parallel pump configuration, we can see that both of them are having that the head is reducing as the volume flow rate is increasing. But for the volume flow rate in the series pump configuration, the head is increasing drastically. The head is reducing drastically as the volume flow rate is increasing. So let's have a discussion on the question. The first question: compare the experiment common curve to its theoretical curve and describe the discrepancy factor. From the curve that we can observe from the left hand side, which I have depicted in the slide, it is known that the head of the series pump is slightly higher than the parallel pump, and in the experimental curve, the flow rate of the theoretical curve which states that the flow rate in the parallel pump is higher than the series. This is because of fluctuation in the experiment that may be occurred during the experiment, which is could be the internal friction loss within the pump and the viscosity of the fluid as well. As for the second question, from the result obtained, state the use of parallel and series pump. So from the results, the total head of the series pump configuration increased while maintaining the flow rate, whereas as for the parallel arrangement configuration, the total head tend to remain same while the flow rate is increased. So from this, it is clearly known that the series pump are to enhance the pressure from one to another, which might be behind or in front of the pump, while the parallel pump is to increase the flow rate and cause greater fluid friction loss within themselves. So as for third question, explain why the system in series configuration would generate higher pressure than the parallel pump configuration. So whenever we're talking about the series configuration and the parallel configuration pump, so as for the series configuration pump, the pump is arranged in a series way, which might be the side by side or in front back, or else by side by side. So for the parallel arranged pump, the pump will be in a different elevation level, which is both of them will be experiencing and sharing the same amount of pressure. So from this, we can know that the parallel pump will be having the lesser pressure compared with the series pump, because series pump will be involving two pump will be involving two different pressure. So this makes the pressure will be added simultaneously from one to another pump. So clearly, this is the reason that the series arrangement pump will be having a higher and greater pressure than the parallel configured pump. So that's all from me. Thank you.
Hello, my name is Muhammad Ediskan Nabi Muhammad Saidi. My metric number is MA19046. So I will continue present about the chapter 5, which is a conclusion. In conclusion, pumps are machinery that convert mechanical energy from an engine into fluid energy to cause liquid to flow. From the experiment, we learned that using series pump increase the total head of the flow, whereas using parallel pump result in a similar total head of the flow but a higher water flow rate. As can be seen from the graph, a series pump system produces more pressure than a parallel pump configuration. Hence, the pump head will drop as the flow rate increase. The greater the head, the more pressure the pump displays. A series pump produces more pressure than a parallel pump. The industry will apply series and parallel pump depending on the application of the pump and the need of high or low pressure of the pump, and also consider the flow rate of the application. That's all from me. Thank you.